Hello, we are Team Farmers, and for our project we were given two sponsors, McFarlane Manufacturing and Nichols Tillage Tools as a co-sponsor. McFarlane Manufacturing is an agricultural company that specializes in equipment for seedbed preparation. For our problem statement, we were given a Spur-Till design that was breaking in the field during use that would leave behind hazardous tines in the field.
Our primary goal was to stop these Spur-Tills from breaking in the field by creating a third Spur-Till design using a different manufacturing method. The first method that McFarlane has tested is a weldment design, and the second design is a casting design that has seen a lot of issues with side loading, resulting in displacement of the tines.
All right, so the first part of our project was to design a test fixture. So that started with forming the design requirements, which was a front and side loading case for the Spur-Till, front and side loading on the tines themselves, and to the ability to apply at least 1,500 pounds of force. So from that, we created a CAD model, which then led into a structural analysis using a finite element model. It was designed to withstand 4,000 pounds of load at a factor safety of 2. And the manufacturing method to build it was chosen to be steel tubes and water jet plates welded together in order to achieve the strength that we needed. And then and the final picture you can see on the right is the final test fixture fully assembled and welded for testing.
The second part of our project was to design a new Spur-Till that was using a form press manufacturing process, which the sponsor wanted us to pursue. So with the help of Nichols Tillage Tools, we were able to add ribbing to their initial geometry that they gave to us, and they performed a simulation to ensure that it was able to be manufacturable with this new manufacturing process. And then once we had that final geometry, our team was able to use CAD models to perform FEA and to compare the stresses to the baseline weldment and to ensure that it matches its performance.
So for the testing fixture, it consists of a steel frame, a 3-ton hydraulic jack, and then for data acquisition, it has a load cell amplifier, Arduino, and voltage divider, which you can see in the picture in the top right. And then the till fixture is adjustable for both load cases, and then this is all powered by a 24-volt DC power supply. For the Spur-Till design, it is made of 4140 steel, has ribbing, like Michael mentioned, to increase strength. It's made through the stamping manufacturing process and has a 3/8 inch thickness.
We did our testing in increments of 250 pounds with a 30-second hold at each stage. We observed a small amount of yielding during the testing as seen in the video in the middle of the screen, and at around 1,100 pounds of load, our actuator began to move out of plane, which led to a comprehensive review of the test fixture design to allow the sponsor to make changes for higher loading in the future.